Good morning, good afternoon, or good evening, depending on where you are. And thank you for joining this learning experience brought to you by JFrog. My name is Cody, and welcome back to Techstrong Learning. Before we dive into this session, I have just a couple of notes to review with you. First of all, we are recording our program today. So if you happen to miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we will be sure to send you a copy of the recording via email shortly after we conclude this live session today. Now, if you'd like to get involved, there are a few ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions for Melissa, we do want you to submit those to the Q&A tab that's also found on that right side of your screen. We do have a couple of polls that we'll be launching throughout our program, so keep an eye out for those as they pop up on your screen. And I will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible for this giveaway are to send in your chats, send in questions, and to fill out our survey, which is both in the handouts and I'll post it in the chat toward the end of our session. So without further ado, let's dive right in. Our topic today is don't expect developers to be security experts. I'm joined today by Melissa McKay, developer advocate at JFrog. Melissa, thank you so much for joining us today here at Techstrong Learning. I'll turn the program on over to you.
Thank you very much. It's good to have you all here today. I am actually based in Denver, so it's a little bit dark here right now, but I know we have folks joining from all over the world. So what's one of my favorite things about these virtual events like this? So yeah, we're going to talk about developers being security experts and a little bit about whether they should be or in what way they should be. But first, let me talk about my background just a little bit. First and foremost, I'm a developer myself. So most of my talks and sessions are from a developer perspective. This is just what naturally comes to me. But in the last 5 years, I became more of a public speaker in developer relations. And actually, recent promotion, became head of DevRel here at JFrog. I also worked on writing a book, DevOps Tools for Java Developers. Java is my primary coding language. I worked in server-side Java for many, many years. And during that period of time, also became a Java champion and did some work with the Docker captains as well. Here's my Twitter or X tag and my handle, and my LinkedIn if you'd like to follow me. And now that you know a little bit about me, though, I would like to know a little bit more about you. We have a poll question here. It's important for us to know, where you're coming from because we want to understand our audience a little bit better. And these are pretty general categories. I know that a lot of us cross over into, each of these areas, but try to do the best you can. Usually we all have like a primary place as developers or software engineers where we live. So go ahead and let us know. What type of developer or engineer are you? Are you more involved in ops? Are you specifically a developer? For many years, I was definitely in a developer silo. We didn't do a lot with ops. That's part of my story I'll be talking about here today. All right, so let's go ahead and move on. The story kind of begins a little bit, a lot of the details at least came from an experience I had recently with Damian Curry. He is with Nginx and F5. He's the business dev technical director there. And we decided to work on a project together just to talk about and describe all of the complications, all of the details around getting a software project out from development all the way to production. I came more from the developer side. He came more from the ops side. So we had a lot to learn from each other. And a lot of the series, we went through various stages of this, getting this particular project out. We talked about planning for it. We talked about setting it up. And then we talked about security. How do we secure this all the way from development all the way to production as well? And we talked about deploying, day 2 issues, like the project's already out there. Now we need an update. Now what do we do? And then the last part, we talked about observing the project. This one often gets missed sometimes. Once a project is out there, your work isn't done. You actually need to observe it, collect metrics, collect information about your project, how it's being used, and get that information back into the development lifecycle so you can continue to make improvements. The most interesting one for me was episode number 3, the one where we considered security. The reason this was most interesting to me is just because of how I came into security as a developer from a developer perspective. This was not something that I was really familiar with. It wasn't something I was super trained in or really learned about. In fact, if you might recognize this particular web page, this is one that I was given as one of my, it was a JIRA ticket to make sure that this page didn't show up in a particular web app that we had. And this was my first introduction to security. And of course, I wanted to know why. Why did we care about whether this page showed up? And this had to do with obfuscation. And, how many of you have taken a security class for developers? This was the first time it really occurred to me that stuff like this could cause a problem. Obfuscation, as we know, is not the best way to secure your application. But the reason we were hiding this page is because we wanted to hide the version of the web server we happen to be using. This way, if there happened to be a weakness or, something wrong with this particular version, maybe we wouldn't get attacked. So we know that we can agree that downtime for any reason is a problem. And I do remember a project once in the past that I worked on where this was exactly the case. We had a web server that got attacked immediately as soon as it was deployed. And thankfully, it wasn't a production deployment. It was more of a test deployment. We were contractors on this particular project. But, this is a problem. It costs time. It costs money. Not only your developer time, to fix it, ops time to fix it, but also, hopefully not, but sometimes it can cost in your customers. You may lose credibility. You may even be in a situation where you've got to pay some damages to customers. That happens a lot when, data, for example, has been released. I don't know how many of you have gotten any of those letters in the mail about your data getting stolen. I know I've gotten a few over the past couple of years even, and it's getting a little exhausting trying to keep up with all of that. Anyway, let's whip through some of these famous hacks. These are old, but they're still very important to note, especially for developers when they're getting an introduction to security. This particular one, it happened with Equifax. It was the Apache Struts vulnerability, and it progressed beginning in March all the way through July of 2017. $1.4 billion is estimated in cleanup costs, 1.38 billion in consumer claims. This affected 143 million customers. This was pretty big. We heard a lot of media about it. There was a lot of fear about it. This is a place that no one really wants to be. And unfortunately, this was something that was preventable. Another one, Log4Shell. I'm a Java developer, so this one came near and dear to my heart. This was particularly a problem, especially in the time it took for everyone to get everything updated. According to the VP of product at Sonatype, there were approximately 70,000 open source projects that used Log4j as a direct dependency. 174,000 used it as a transitive dependency. Just about every Java developer out there cringed their way through fixing this vulnerability. One interesting thing about this one in particular is we knew the version that was a problem. We had a patch, we had something ready to replace it with. However, there may have been a lot of times when it wasn't really necessary. It could be that there was a dependency that relied on this log or that included this log4j package, but maybe wasn't using it in a way that made it a problem for the application. So just to be safe, I think, in general, everyone just wanted to see nothing of the old log4j package, get rid of it, make sure everything was updated. All right, another one. This is actually a website that I go to pretty frequently just to get some updates on the latest data breaches, especially when I get those letters in the mail warning me that my data might be out there somewhere. And this one, data is a huge motivator for hackers due to its immense value. And quick search in Google will reveal all kinds of data breaches. And this particular website updates frequently. There's several every month. The last time I looked at it, it was updated in March 21st, and there were 6 data breaches already recorded in January, February, and March of this year. There were 3 last year that I pulled out that interested me because they all had to do with this Move It software. And this one is important because it highlights a specific type of vulnerability, and it's just, using a piece of software that has been made malicious somehow. An update was made to it that, caused some problems. The first one, the Move It hack affecting, zealous British Airways, BBC, and others, pretty serious. I mean, it's not comfortable to, especially to be, sitting on a plane or something, or, have your, services and systems that you rely on and use have it possibly be affected in this way. The July 20th, the PokerStars data breach. This is the world's largest online poker platform, and they suffered a data breach exposing the information of 110,000 users. This is pretty serious. And then, in August 11th, the IBM data breach. This one was close to me because it was in Colorado. 4.1 million patients in Colorado had their sensitive healthcare stolen. So pretty serious. So it's not only even, the software that we write, it's the software that we use, the tools that we use. And do you pause to think about your tool chain and everything that you have installed on your machine, or everything that you use in your development processes day to day? The global average cost of a data breach in 2023 was $4.45 million US dollars. That's a 15% increase over 3 years. So this isn't something that seems to be getting better, seems to be getting worse. And there's a lot of things that we need to consider to help improve this. We'll talk about more of those later. But initially, this seems like a sensible statement, right? As a developer, it is my responsibility to write code that is secure. This does sound reasonable. This is certainly something that I felt as a developer when I started learning about these things, especially about code weaknesses, things like that. These are definitely things that I have control over as a developer. There's a lot of resources available to us, especially with all the high-profile attacks that we've heard in the media. It's important to go out there and find these resources. There's quite a few third-party organizations that can be hired by corporations to train their developers internally. I highly recommend that approach. I found this essay. It is a joke essay. I found it on the OWASP website. That's the Open Web Application Security Project. They have a lot of resources that are related to the security of software. And this particular essay, if you enjoy a little bit of sarcasm, it actually tells you all of the ways to not secure your application. A few of them I had to pull out because they were pretty funny. Mainly, relying on security checks done elsewhere. It's redundant to do security checks twice. So if someone else says that they've done a check, there's no point in doing it again. This one makes me chuckle because a lot of developer teams feel this way a little bit. We already have a lot of stuff that we're responsible for, and we've got the tools in our toolbox that we're used to using. And many developers take for granted that there are other places in the company that will safeguard anything that goes out into production. Unfortunately, that is not always the case. We need to support each other, with the different teams. Security teams and development teams should be communicating with each other. I'll let you go read that essay. Definitely take a look at it. It's pretty entertaining. So let's talk about educating developers in the beginning. You learn to kind of think like a criminal. And remember, I talked about hiring third-party training. There's options for that. And I was really lucky in my past that I actually worked for a company that did just that. And the training was actually even focused on the primary development language, because each language has its own weaknesses, its own places that can introduce vulnerabilities if you're not careful. So I learned all about cross-site scripting. I learned about SQL injection, how to protect against that, LDAP injection. I learned about cross-site request forgery. I learned about insecure cryptographic storage. And I really thought I knew my stuff at this point. And, what more can a developer be concerned with? So I, left this training thinking we're done. We're all secure. It's time to move on. So even though I'm confident that I can avoid writing weak code, it turns out that I actually use a ton of code that I didn't write. And it's estimated that 70 to 90% of any given piece of modern software solutions, use free and open source software. This is not an unrealistic number, because if you think about it, developers don't want to reinvent the wheel. In order to progress, in order to add new features, to get ahead of the game, we're going to be using stuff, pulling in tools, pulling in frameworks, pulling in packages that help us get ahead of the game and to help us write our software, write more advanced and complicated software. Turns out this was the case with all the software I wrote too. There's a bunch of other stuff that gets pulled in during the build. The project that I brought up earlier, the one that I worked on with Damien at F5, this particular project was a Java microservices project. And I just wanted to figure out just how many dependencies were in this particular project. I picked just one of the components, and it turned out that there were 114 direct and indirect dependencies in this particular component. But notice it was also 7 layers deep. So this is dependencies that had dependencies that had dependencies that had dependencies. Now, anyone that's worked with Java and maybe perhaps Maven, you may have run into the whole, it's called dependency hell. This is an interesting state that you can get in where maybe a dependency of a dependency of a dependency is relying on a particular version that is incompatible with a version of a completely different dependency. So I was very, very familiar with navigating this particular problem and understanding that there's a lot of stuff out there, a lot of code out there that you're going to be pulling in that you're never going to look at. So it seems pretty scary, pretty easy to accidentally introduce something malicious and not know about it for quite some time. This particular application actually consisted of 7 microservices. This was just one of them. So good example of the problem that we have. Synopsys, they have a report of the usage of open source software. This was released in 2023. And they scanned 1,703 commercial code bases across 17 industries. Now, these reports, a lot of companies put out these reports and stuff. I like to give you those numbers, the facts that it was 1,703 commercial code bases. Always look for that information in these reports. The data, where the data actually came from, what they're actually using. It can be enlightening sometimes. But this one was particularly interesting. I appreciated how many code bases they scanned, 17 industries, very interesting. Bunch of interesting stuff. Definitely go take a look at this report. But I pulled out these three. These are three graphs from three of the industries I just thought were most interesting. I took these directly from the section on the use of open source. And just notice, how much open source is being used in these projects. And then also that red line, the percentage of code bases that contained high-risk vulnerabilities. So not only was there a lot of open source being used, but there's a lot of vulnerabilities being used. Now, these are related, but it doesn't mean that all open source is bad or that you shouldn't be using it. That's not what I'm saying here at all. I'm just saying that there is a relationship between, possibly having high-risk vulnerabilities if you're not keeping up with updates of your dependencies, as well as the software that you're writing. So these are things that we need to pay more attention to as developers, and understand exactly how our projects and how they're being built and what exactly the components are that are being brought in. Notice that in 2020, there seems to be like an interesting peak there. That would be an interesting discussion to have, is why that peaked in 2020. I can only think that maybe there were a lot of people at home sitting around wondering what they can do. This was either a time when more vulnerabilities were introduced, or maybe a time where more were just discovered. So that would be an interesting talk over coffee with some other developers, I would think. So again, we're back to this statement. If developers didn't write insecure code, then we wouldn't have any of these problems. This is now starting to feel a little bit naive, right? Is it all up to developers? One of the best parts of my career was moving from that isolated developer area into a DevOps team. This happened, several years ago. And I learned just how much there is involved, not only in developing software, but the process to get it there, the process to deploy the software, how many different tools that there are that are being used to deploy and then to monitor software once it's out there for the public. It's a lot for a developer to take on. I'm going to go off on a little bit of an aside because I think you'll notice the metaphor here. I love Rube Goldberg machines. I love them. In fact, I'll come across them every now and then when I'm traveling through airports. And there was one in Seattle that I stopped and took a look at. There were a couple of Rube Goldberg machines there. And, just so you know, the Rube Goldberg, he was famous not for actually building these machines, but for drawing them in cartoons. Building them is something that came later, and that's for a lot of us today to have fun with. But also, he's famous. His name is in the dictionary as a, this is something he's famous for, something to strive to, right? To get your name in the dictionary. Pretty exciting. But anyway, I wanted to go out and see what if there's any, record-breaking Rube Goldberg machines. And I did a quick Google search, and this is the largest Rube Goldberg machine. There was this video posted on December 10th, 2021. This whole machine took 4 minutes and 26 seconds to run, and they made it into the Guinness Book of World Records. The whole machine has 427 steps. And see how happy these people are at the end. This is just exactly how happy I was as a developer when I was moved to a DevOps team and given the task of building out our web server, or our pipelines, our build pipelines. And when I got our first Jenkins pipeline actually running and working, that's about how happy I was. So yeah, I'm going to say that software, the process of getting it developed, getting it out there, is definitely like a Rube Goldberg machine sometimes. There's a lot of tools, and it cannot be all up to developers. There is a lot of other teams that are involved in this, and all of us need to work together in order to make sure that our software is protected. There's a specific example of this. I don't know if you remember this particular attack, the SolarWinds attack. There were 4,000 lines of malicious code that was added to the Orion platform DLL. The interesting part about this is it was done after compilation. This implied that the binary may have been switched in the continuous integration system. 18,000 customers received an update that included malicious code with a backdoor. What made it even foolproof was the fact that the compromised file was digitally signed. So it did suggest that the attackers had access to the SolarWinds software development distribution pipeline. So here's a very good example of why this is not all on the developer's plate. This is a slide that I see in our JFrog corporate decks, just kind of showing the environment that you might be in when you're developing software. It gives you all the steps. You've got your developer. They are, retrieving packages from remote repositories, public repositories. They're making changes to their code. They're submitting this code to source control. This code is then being, that may trigger a build in a build server. We've got all the list of different kinds of build servers here. This is a huge ecosystem of a number of different tools. But look at all the red lines, the red arrows that I put on this slide. These are all the places where we refer to artifacts and dependencies. There's a lot of places here where we can get tripped up by a malicious actor that aren't directly related to the developer, but maybe to the process of getting our software out there. A lot of that is described in the supply chain security. And one of the attempts at describing this has been done by Salsa. Definitely check this group out if you haven't. Salsa is a framework that attempts to measure an organization's progress and help give them goals to improve. So it's the description of where you're at, where your particular development team is at, and or where your software is at, how secure it is already, and where you might need to put in some better protections. So each of the little red triangles here, they're very similar to the red arrows that I pointed out earlier in the previous slide. These are all places where you could potentially get, some malicious behavior happening or a piece of software that is unexpected. All of these places you need to figure out where they are in your process. One thing that I did with previous development teams was whiteboard. We did like a little threat analysis of the whole process. And it was pretty surprising the things that came out, because each team, we were all had our expertise in certain areas. Developers are more, on the left side, that, more in that area. So it was interesting to see all of the holes that happen, not only in that area, but also afterward, where dependencies are being pulled from, where the build server itself is pulling dependencies. Sometimes we were surprised by the fact that sometimes we were consistently reaching out to a public repo for dependencies. That's not necessarily a bad thing, but probably not something you want to repeatedly do. You should be bringing in everything, all the components that your software needs. You should be bringing that in to your internally and being able to track all of those versions and all of those dependencies. So here's another type of attack. This was something relatively new that I learned about, and it was described to me, and I was floored how this works. So I'm a Java developer, but rarely do I meet a Java developer that isn't doing something else. I mean, oftentimes we had, Java server-side projects that used, JavaScript for our front end. We might even have a completely different development team working on that part of the project. So what you see here, what I'm going to describe here is the dependency confusion attack. This was described in detail by Alex Burson in a blog on medium.com a few years ago. Excuse me. It turns out that most projects, have a collection of dependencies that need to be collected And they include open source or publicly available packages, as well as internal packages. The internal packages, maybe components that are built by other teams within the organization that you use in order to build your own component. And these package names are highlighted here in yellow are some examples of internal package names, but these package names are not secret. So when you do an NPM request inform about internal package names. So let's describe how that looks. A request is made for a corporate library, and the expectation is that it will come from some internal repository. And instead of specifying a version, we indicate that we want the latest version. Now I'm going to go back to the previous slide just to explain something. See the version numbers that are next to all of these package names that are highlighted in yellow? And see that little caret? If you don't already know, that means that we want either that version that's specified or a greater version. This is where it gets tricky. So we want this corporate library. We want the version specified or a greater version that has been updated, which is good practice. We assume we're going to get version 1.2, the latest version. But by default, we're going to be going out to the public NPM repo and we're going to get the greatest version, because 1.2 is not necessarily the greatest version. It is very possible that someone has a library named exactly the same that is in the public repository, and NPM will prioritize that one over the internal one. So now you understand what I mean when I say those package names aren't a secret. So it is quite easy for a hacker or someone with malicious intent to find internal package names, create their own packages with those same names, and upload them to the public NPM repository. One way to address this is just to stop external requests. So if you had something like Artifactory, there is a setting in there where you can avoid, if you're expecting an internal package name, you can prevent the public request to the public NPM repository. This attack came with a lot of media as well. That vulnerability has been around forever, but it's never really been described in detail like Alice Burson did. And there's a few other details he outlined. So I added a QR code here for the original Medium article. But all of this resulted in some pretty large bug bounties. So a lot of money in this, for sure. All right, here's another one, another fun one. This problem has more to do with managing open source packages and libraries themselves, not really about a malicious package or a vulnerable package. It's more about the maintenance of packages that you use regularly. And this illustration, this is XKCD, is one of my favorites. It's most of you might have already seen this. This is a pretty popular one that has been going around. It illustrates a trap that we fall into when we rely solely on public repositories for our build. If we're always and consistently requesting a public package, there could be a day when it's not there anymore. Also, when you're choosing a package like that, you might want to consider, is it being maintained well? This all comes down to being thoughtful in your choices when you're bringing in open source into your project. That's a whole nother area of concern. And here's a good example. I don't know how many of you remember this particular incident, the left pad incident. Basically, there was a kick package out there on NPM, and a developer created this kick package, but it just so happened that there was a kick organization. And the organization wanted to name their package the same name. Well, the developer and the kick organization couldn't come to an agreement on an NPM package name. So NPM they took it to NPM. NPM sided with the kick organization because they agreed that when NPM users request a package, they need to get what they expect. This helps eliminate things like typo squatting. And under the dispute policy, an existing package with a disputed name, it typically remains on the NPM registry, and the new owner of the name publishes their package with a breaking version number. Well, what happened instead is the developer was upset at this decision. I can only presume that was the case. And he decided to unpublish his kick package. Well, there were 272 other packages that he also unpublished. And one of these packages was LeftPad. LeftPad was relied on by a lot of software out there. I believe Facebook was one of them. And fortunately, in a short period of time, a developer named Cameron Westland stepped in and made the hero move of publishing a functionally identical version of LeftPad. He made it version 1.0.0, but many of the projects were explicitly requesting version 0.0.3. That is also a good practice because you don't necessarily want things updating out from under you. So if you remember in that previous slide when we talked about the carrot, getting either the package version or a later version. Well, a lot of these packages didn't have that carrot. They were explicitly looking for version 0.0.3, which did not exist anymore. So yeah, back in 2016, a lot of stuff exploded because of this code right here. That is all the package contained. That is all LeftPad was. So pretty interesting stuff. Okay, let's talk a little bit about containers. Back when I just first started working with Docker containers, there was a lot of trial and error going on there. This was a new technology for myself and my team. We had a lot to learn. We did a lot of things wrong in the beginning. And I put this file together. There's a combination of problems here. It's very contrived. By no means is it a stellar example of how to build a container image, but it's a good illustration of some problems that are pretty common that you will likely see in a lot of examples out there, because examples are just the simplest thing that works. They're not necessarily the most secure thing that you should be putting into production. So I'm just going to go through, there's a lot of issues here. I'm just going to pick out a couple, maybe 2 or 3 of them. So line 1, there's no tag or SHA identifier here. We don't know where this image is coming from. Well, by default, it would be coming from Docker Hub. If we haven't gone and looked at this particular base image and understand where it's coming from, who manages it, who maintains it, what does it contain, all of this is unknown. And they're probably not as, named like this in a way to even warn you, untrusted parent image. Likely you're going to get a lot of very common named images that people use all the time. And if you're not paying attention, you could be bringing in some stuff that you don't intend. Lines 2 through 4, often we'll use a base image and then we need to make some updates. Here again, we're not specifying any versions and we're not keeping up with updates on the one that does have a version explicitly defined here. Let's look at line 6. I see this a lot in examples. Basically, this could be more of an efficiency and performance problem, but possibly a security problem as well. This is basically copying everything in your directory, putting it into the image. So think about this could include your Git directory. This could include maybe keys that you have on your system. Maybe even, developer-only stuff that you really don't want to have in a production image. There could be some issues here. What you should be doing is using a .docker ignore file in order to prevent those types of things from being copied into a production image. It works very much like a git ignore file. Line 7, relying on external resources. This is definitely something that I had a problem with at one of our trial and error situations. We had a proprietary piece of software that we needed to install and inside of an image, and we were given a script basically from the company in order to do this. Well, we just used curl to install it, and obviously when you're relying on a third party location for something, you can't always assume that it's always going to be there. And sure enough, they've got their own priorities and their own needs. They moved it. So right away, our builds broke because now the location was different. And we didn't learn our lesson then. We waited until the next problem where they updated the script, and they updated it in such a way that it was incompatible with how we were using it. So again, all of our build scripts failed. So if you have something like this, the best thing to do is don't consistently request it from the third-party source. You need to bring it into your internal system, store it in an artifact management system like Artifactory, for example. Make sure that you have it readily available to you and your team always. This is another thing for containers. I feel bad talking about this, but in a 2022 SysTick report, 76% of the containers that they observed, that was out of 3 million containers, 76% of them were running as root. Whether they were legitimately running as root, not sure, possibly, but that seems like a very high number for that to be the case. Do you think this got better than next year's report? Let me give you a second to think about that. Did we get better in 2023? No, we did not. Now we're up to 83% of containers running as root. All right, a lot of you might feel pretty overwhelmed. There's a lot of stuff here. Is there any hope for us? Well, let's talk about what has been done. This is clearly a big enough problem. We're now in the situation where we have government regulation coming down the pipe. We have the creation of CVE, NVD, and CNAs. CVEs, if you don't know, they're common vulnerabilities and exposures. The National Vulnerability Database is supposed to be keeping up with these. Interesting, recent news that maybe possibly they aren't keeping up with these. This is a concern that we're all worried about. JFrog is actually a CNA. Which means we are a CVE numbering authority. So when we find a CVE and we are actively looking for them, we will register them. We actually have a website called research.jfrog.com. Lots of information there, lots of interesting stuff there. I encourage you to check it out. We need to talk about this more. I know last year, the White House had a security gathering, open source security summit. That was pretty interesting. I'm hoping that we, keep up with that. And then, of course, education. We just need to make sure that people understand and we know what to look for. Developers especially. So we need to educate ourselves. There's the OWASP resources. The Docker file that I showed you, which was very simple, very contrived. There's a ton of more information here in this cheat sheet. Put a QR code here for you. A ton of information here on how to improve your security for your software. And a lot of it, they have a container specific section as well, along with a lot of other things. And it's free. That's the best thing about this. There's a lot of information out there that's free. The OpenSSF has a trio of free courses. That's an organization that's under the Linux Foundation. These courses are free. You can pay to get a certificate if you like, but you can take them at no charge. There's some QR codes here for you. These slides will be provided to you as well. So you'll have some resources to go look at later. All right, we talked about public repos, relying on them solely and how that can be a problem. We need to manage dependencies. This does not only include the dependencies that you're pulling in with your software, but it includes your tooling and the frameworks that you use. We did touch on the fact that it's not all about the code that you're writing. There are some holes that need to be plugged throughout the process of getting your software built and deployed. Do you recognize this? This just describes, the environment that we live in. These are all the, a lot of the tools that you could possibly be using for your projects. Obviously, you're not going to be picking and choosing through all of these, but it just shows how overwhelming this can be, the ecosystem can be, how much we need to look at, and especially a lot of the code that we don't write. It's just stuff that we use. This is actually the CNCF landscape. it's a very good description of the environment that we all live in. And this is just for fun. I enjoy jigsaw puzzles. So I found this. Unfortunately, it was all sold out, 42 sales, but this is something that is interesting enough. I might try to create a puzzle like this myself. Another thing that we can look at is foundation support. I talked about the Linux Foundation a little bit. There's two organizations underneath the Linux Foundation, the CNCF, Cloud Native Computing Foundation, and another one, a sister org called the CD Foundation, which focuses more on CI/CD solutions like Jenkins, Spinnaker, Tecton, among some others. The reason I bring these up is because when you're looking for open source projects to use, you might want to look at how they're being maintained and how they're being governed. There's good accountability with these organizations. And this is just an example of what you can find in the CNCF. This is for software projects that go through graduation. And in order to graduate to specific stages, they need to complete an independent and third-party security audit. So something that can help satisfy your needs as far as security compliance. When you're choosing open source software, you might want to choose one that's governed in this way. We talked about managing permissions, just that the principle of least privilege, the principle that security architecture should be designed so that each entity is granted the minimum system resources and authorizations that you need to perform a function. It's so easy to get lazy here. I can't tell you how many times I've just been granted admin permissions just for convenience and how unsafe that actually is. And not only for, possible malicious reasons, but just for accidents that happen, accidentally deploying test software or tools or anything onto production resources. That's something that I've seen happen just because we don't have the permissions protected well enough. Keeping up with maintenance, definitely keeping up your dependencies and your current software, making sure that you're addressing known CVEs as they come up. Make sure that you are regularly scanning your libraries and packages. There's some considerations to take here. I'm going to go through these pretty quick. But when you're choosing tools to scan for CVEs, if there's no context or mitigation info, this is pretty overwhelming, especially for developers. There's this whole move to push security left and have developers deal with some of this. But if you hand developers a list of CVEs with no information on how to fix it or the version that fixes it or how to, what to even pay attention to, that is not the best way to go. And then also, is it disruptive or does it force a developer outside of their normal development environment? And then, we need to be able to prioritize applicable vulnerabilities. So remember earlier in this session, I talked about Log4j, how there were a lot of updates that probably happened that didn't really need to happen because maybe in those situations, it wasn't really applicable. But at the time, we didn't have enough time to spend thinking about that. So everyone just worried, made sure that they got everything updated regardless. Here's some examples of what I'm talking about as far as, integrating into a development environment. This is a plugin for IntelliJ, or not for IntelliJ, sorry. We have one for IntelliJ as well, but this is VS Code specifically, that just kind of describes CVEs that are found in the code and gives you some remediation information, gives you details about the CVE. This is all helpful for developers to be able to prioritize these fixes. And then, if you're a person that works in, Docker quite a bit, you might be using Docker Desktop. Here's another plugin that JFrog offers that you can add to your Docker Desktop to do some scanning of the images that you have on your local system. These are deep scans, by the way. They go, all the way into the base image as well and tell you exactly where a problem exists. And then optimizing your CI/CD processes, protecting them. Remember the SolarWinds example. Another you think to ask yourself, are you rebuilding your software when you release? When you decide, okay, we've tested everything, now it's time to release. At that point, do you actually rebuild? You shouldn't. You should be using the build that was tested, because there's always a risk of bringing in something new at that point that you might not want. Are your build servers protected appropriately? Also a SolarWinds teaching moment. And are you pulling your build and release artifacts from a known and secure location rather than consistently pulling them from third-party sources or public sources where they could be updated out from under you? These are all things to consider. Now, who should care about this? I'm just going to finish off with this list of pretty much everyone: developers, operations, DevOps teams, platform teams, security teams, management, and the C-level. You need a culture that cares about this, that provides the resources that every team needs. And this is going to take a multi-pronged approach. I'm hoping that as we move forward in the future, we will get better at this. But ultimately, don't expect developers to be security experts. Empower them. Don't just give them a list of CVEs, because they definitely are not security experts. All right, we have a little bit of time for questions.
Awesome. Thanks, Melissa. Let me go ahead and pull up these questions. We did receive a couple. All right, so our first one reads, what are some effective strategies for integrating security measures into existing development workflows without significant disruption?
So I know, for example, one of the things, we have a product called X-Ray. And something that I see often is, people want to use the policies that prevent developers from downloading or using dependencies, for example, that have CVEs. And then the first thing they might do is block everything and maybe block the build. You absolutely don't want to do that. You need to take a staged approach and accept that it will take time. So the biggest, most important thing to do is be aware of what you have. So make sure to absolutely do those scans, but don't block your builds right away. Don't block, deployments right away. This is something that you need to spend some time prioritizing a list of perhaps vulnerabilities that you want to fix that are, most important. That's going to be based on applicability. It's going to be based on severity, and possibly even, like the environment that you're running in, in that case, maybe some aren't even applicable. So this is where the security team can certainly help. They can provide, help with prioritizing these kinds of things. And then as you prioritize and fix those, then harden up your policies to prevent future projects and teams from using those dependencies moving forward. So yeah, slow but steady.
Awesome. Thank you, Melissa. It looks like we might have time here for one more. So with the vast number of scanning tools available, which we saw on the puzzle, how should a team go about selecting the right one for their projects?
So something I would encourage you to ask on each of these tools, so the makers of these tools, there's a lot that are open source and there's a lot that you pay for. And the biggest differences between them are going to be the databases and the sources of information. You may find when you're comparing these tools that one tool will give you a bigger list of things to address than the other tool. Another thing to make sure of is that you're also getting dependencies, like transitive dependencies, that are getting addressed. So you don't want a tool that's simply looking at like a POM file, for example, or just the top level dependencies and stuff. You want something that's going to go deeper than that. So that's the main thing. Make sure to request and get a for sure answer on what the sources of information are you're getting. Some of them are paid, so that's why you're having to pay for some of these products. And I have to brag about JFrog a little bit here, just because we have an internal research team, right? We are CNA, so we're probably going to find things first, in many cases, before everyone else gets access to it.
Awesome. Well, Melissa, it looks like we don't have any more questions, but we do have a couple more minutes. So I did want to give you the opportunity to leave us with any parting words or final thoughts before we take things off the air.
All right. Well, for all of you developers out there, stay strong. We are going to get better at this. I encourage you to get involved in the organizations like OpenSSF and keep track of what's going on there, the latest things that are happening, the latest pushes, the latest regulations that we're going to need to worry about in the future. And also, I think we have one more poll too, like if you're interested in getting any kind of demo or anything, just reach out to us and let us know.
Yes, we did launch that poll, but that also does segue. We do have that in our survey. If you would like to leave us some feedback there, you're welcome to as well. Melissa, thank you so much for joining us here on Techstrong Learning. It's been such a pleasure having you.
Thanks for having me.
So for the rest of our audience, before I dismiss you, just a couple reminders. Today's session was recorded, and we will be sending it to you as soon as it becomes available. You can also find it living on the DevOps website. Just visit devops.com/webinars. I'd like to thank JFrog for sponsoring our program today. And to our audience, thank you so much for spending time with us. We really appreciate you being here. And just one last call out, if you would fill out that survey for us, we'd really appreciate that. But otherwise, we do hope to see everyone at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Melissa.
Thank you.